For millions of years, something ruled the oceans. Not a whale, not a dinosaur, not even the great white shark. It was larger, more powerful, and so perfectly adapted that almost nothing could challenge it. Then, it vanished, without warning, without a trace, leaving behind only enormous teeth and a mystery that scientists believed they had already solved. But what if almost everything we thought we knew was wrong? Recent discoveries have completely changed our understanding of this ancient predator, its appearance, its size, even the way it lived. This is the true story of Megalodon. Welcome to Planet Creatures. Today, we're traveling millions of years into Earth's past, not just to meet the largest hunting shark that ever lived, but to uncover one of the greatest scientific mysteries hidden beneath the ocean. For more than 100 years, scientists believed they had successfully reconstructed this prehistoric giant, its jaws, its body, even the way it hunted. But recent discoveries are challenging those long-held beliefs, forcing researchers to rethink everything they thought they knew. Together, we'll follow the fossil evidence, explore the discoveries that changed paleontology, and uncover the true story behind one of the most legendary predators in Earth's history. Every fossil has a story. Every discovery changes what we know. Today, we uncover one of the greatest of them all. Let's begin. Its scientific name is Otodus megalodon, the giant tooth. That name is appropriate because teeth are what this shark left behind by the thousands. A shark skeleton is made mostly of cartilage. After death, it usually collapses and disappears before it can fossilize. Teeth are different. They are hard, mineral-rich, and sharks replace them continuously. Over a lifetime, one animal could lose countless teeth into the seafloor. Some megalodon teeth measure more than 17 centimeters from root to tip. They are thick, triangular, and finely serrated, built less like needles and more like heavy cutting blades. To estimate the animal behind them, researchers compare tooth dimensions, associated tooth sets, and rare fossil vertebrae with living lamniform sharks. Every method carries uncertainty, but they all point toward the same conclusion. This was not merely a large shark. It was one of the largest macropredators ever to live. For decades, Megalodon was pictured as little more than an enormous great white shark, enlarged to almost impossible proportions. It became the image everyone recognized, a massive, stocky predator with the familiar shape of the shark we know today. But that image may be wrong. Most reconstructions place large adults somewhere around 15 to 20 meters long. Yet recent work suggests that an exceptional individual may have stretched beyond 24 meters, nearly the length of a blue whale, with a mass approaching 94 tons. That would represent an extreme individual, not the size of every megalodon, but size may not be the biggest surprise, shape is. With no complete body ever found, scientists have always had to infer its outline from the fragments that survived, and newer analyses suggest the classic, oversized great white body may simply have been too bulky to move efficiently at such an enormous scale. Megalodon may instead have been longer and more streamlined, a powerful cruising predator built to cover vast distances efficiently, then accelerate in short bursts when it needed to. Imagine an animal approaching the length of a blue whale, but shaped for pursuit, an enormous head carrying row after row of replaceable cutting blades. Even now, we still don't know its exact fins, color pattern, or precise proportions. So every reconstruction you see is just that, a reconstruction, not a portrait, but a range of possibilities constrained by fossils, anatomy, and physics. Megalodon did not appear from nowhere. It was the final giant in a lineage of megatooth sharks stretching back tens of millions of years. Earlier species, such as Otodus obliquus, had narrower teeth with small side cusplets, well suited for gripping fish. Through time, the teeth became broader, the cutting edges developed serrations, and the side cusplets diminished. The weapon was changing from a fork into a knife. That transformation unfolded as marine mammals diversified, oceans filled with seals, dolphins, small baleen whales, and predatory sperm whales. For a shark lineage already increasing in size, this was an extraordinary opportunity. Warm seas, abundant prey, and vast coastlines connected by open water. By roughly 23 million years ago, Megalodon had arrived. It would persist for nearly 20 million years, far longer than our own species has existed. Size alone does not explain how Megalodon hunted. The strongest clues are written into the bones of its prey. Fossil whales and other marine mammals have been found with deep gouges, punctures, and serrated bite marks consistent with megatooth sharks. Some may come from scavenging, but others suggest violent contact with living prey. A small whale was fast, powerful and difficult to hold. Megalodon may have attacked from below or from the side using surprise and momentum. A bite near the chest could damage vital organs, while a strike to the flippers or tail could cripple the animal and prevent escape. Computer models estimate that very large Megalodon could have produced bite forces between roughly 108,000 and 182,000 newtons. These are estimates, not direct measurements, but combined with enormous jaws and serrated teeth, they suggest a devastating bite. Yet that power came at a cost. A predator this large needed enormous amounts of food. Megalodon depended on oceans rich enough to support both giant prey and a giant hunter. Its life may have begun at a size that sounds impossible. A recent reanalysis of growth bands in fossil vertebrae suggests newborn Megalodon could have measured around 3.6 to 3.9 meters, already comparable to a large modern shark. Like living relatives, the embryos may have hatched from eggs inside the mother and fed on additional unfertilized eggs before birth. This behavior, called oophagy, can produce fewer but much larger young. It is an inference, but one consistent with the biology of modern lamniform sharks. Fossils from a shallow, productive sea in what is now Panama contain an unusual concentration of juvenile Megalodon teeth. Researchers interpreted the site as a nursery, a place where young sharks could find food and reduce their exposure to larger predators, including perhaps adult Megalodon. New estimates of very large birth size have reopened the question of how dependent these sharks were on nurseries. The broader lesson remains. Even the ocean's most formidable predator began life vulnerable, and its survival depended on specific habitats. Megalodon fossils have been found across the world. It moved through warm and temperate seas of the Americas, Europe, Africa, Asia, and Australia. This global range made it more than a local monster. It was part of the architecture of marine ecosystems. Predators change prey even when they do not attack. Their presence can influence migration routes, feeding areas, and which animals survive long enough to reproduce. We cannot watch those ancient interactions, but the abundance of Megalodon teeth beside marine mammal fossils reveals a long relationship between hunter and prey. Then, during the late Miocene and early Pliocene, that relationship began to break. Megalodon's abundance declined. Its geographic range contracted, and around 3.6 million years ago, the teeth stopped appearing. Ocean conditions were changing, coastlines and productive shallow habitats shifted, and prey communities changed with them. Some whales became larger, while others moved into colder or more seasonal waters. For an enormous predator with immense energy demands, losing access to reliable prey could be catastrophic. At the same time, another shark was expanding. Great white sharks appear globally by about 4 million years ago, shortly before Megalodon disappears. Chemical evidence suggests the two predators fed at similar trophic levels where their histories overlapped, meaning they may have competed for smaller whales, seals, and other calorie-rich prey. Great whites did not need to fight Megalodon directly. A smaller predator simply needed less food and could survive on prey that might not sustain a giant. Predatory whales and the loss of nursery habitats may have added further pressure, but no single explanation fits everything. The most likely picture is a convergence, changing oceans, altered prey, shrinking range, and new competition acting on an animal whose enormous body demanded abundance. Megalodon survived for almost 20 million years. It did not disappear because it was weak. It vanished because the ocean that created it no longer existed. The deep sea leaves room for mysteries, but not for a hidden population of Megalodon. A breeding population of giant predators would need enormous quantities of food. It would leave fresh teeth, bite marks, carcasses, environmental DNA, and encounters across oceans now crossed by ships, fisheries, cameras, and research surveys. Megalodon was also associated mainly with productive coastal and open marine ecosystems, not an abyss where whales are scarce and temperatures brutally low. Its fossil record ends millions of years ago, and no credible modern tooth or body has ever been verified. The real animal does not need to be alive to be extraordinary. Its extinction is part of the story, and part of the reason modern oceans became what they are. Today, whales have no shark large enough to hunt the biggest among them. The balance of power has changed. But on ancient seafloors, one object still survives. A triangular blade, darkened by time, waiting to remind us that for millions of years, something larger was hunting below.